In this lesson, we're going to use trig functions to model periodic behavior. So we're going to get into a little bit of physics here. Trig functions are used, and typically it's the cosine or the sine function. And today we're going to deal with functions where we do not have a phase shift or a midline shift. So the two functions we're going to look at basically would be y is equal to a times the sine of bt, and y equals a times the cosine of bt. Sometimes instead of using a b, the symbol omega is used here. So you'll see in the blue book that an omega is used, which is a lowercase w. But it means the same thing. It's still the coefficient in front of the variable. And we use t for the variable because in our models, t will represent time. So since we work with time and other numerical values, we work in radians and not degrees. Because of that, we need to make sure that our calculators are put in radian mode. If we're checking our work and trying to graph things, make sure it's in radian mode. So in this case, the amplitude is still going to be the maximum displacement from the center. In terms of examples, it would be a maximum displacement might be how large a wave is. If there's a boat sitting on the water and a wave comes by, like how high that boat will raise from the calm state, or how far a spring is compressed. If you have a spring and you compress it, that would represent the amplitude. The period is going to be the time it required to complete one cycle. So if you have a spring and you compress it and you let go, it would be the time for the spring to stretch out and come back up to the starting position again. The frequency is a new thing. If the period is always, if we're talking about sine and cosine, 2 pi over that coefficient, the b value, the frequency is the reciprocal of that. It is the reciprocal of the period. So it's going to be the b value divided by 2 pi. And that's the number of cycles per time unit. So it depends on what you're talking about. If you're talking about seconds, then the frequency would be cycles per second. And actually, you've probably used that in physics before. The frequency term for cycles per second is called a hertz. And you see that on computers, gigahertz or whatever they are now. That's the processing speed. So if I have either a sine or a cosine curve, which one do I want to use? I kind of figure out, how do I know when to use the sine or the cosine? We think about the standard curves. The sine starts in the middle and ends in the middle, and the cosine starts at max and ends at max. So we have to look at the starting point for our model, and if it's something that starts at the middle position, you're going to use a sine curve. If it's something that starts at either min or max, you're going to use some form of a cosine curve. So we look at the starting point to figure that out. Alright, so for the first part of this, we're just going to identify the amplitude, period, and frequency, and then we'll do a couple of examples, and we'll talk about some more complicated examples in class. But finding the amplitude, period, and frequency, pretty much what we did the other day. We just have to add frequency to it. For our first example here, the amplitude is going to be 3. The period is going to be 2 pi divided by the b value, which is 5. And that makes the frequency 5 over 2 pi. It's just that easy. It's really not a big deal. For the second example, remember I have a negative sign. We don't use that in our amplitude. The amplitude is the absolute value. So the amplitude is going to be 4. The period length is going to be 2 pi over 1/2, which is 4 pi, which makes the frequency 1 over 4 pi. Alright, so I'm going to talk about one example here, and then the other one, the mass spring, we're going to do in the class together. A tuba player plays a note E and sustains the sound for some time. And a pure E is modeled by this function here, 0.2 sine of 80 pi t. V is measured in pounds per square inch, which is a pressure, and T is in seconds. First of all, find the amplitude, period, and frequency of V. So pause this video and see if you can do that. And if you did that, you would get the amplitude is 0.2, and the period is going to be 2 pi over 80 pi. So that ends up to be 1/40th of a second. So the frequency is the reciprocal of that, 40 hertz. So a pure E vibrates at 40 hertz. If the tuba player increases the loudness of the note, what do you think is going to change here? So think to yourself, what would change? Would it be the period or the amplitude? If you think of the word amplitude and think what an amplifier does, an amplifier amplifies the sound, so the amplitude is what's going to change when the loudness changes. So the amplitude would increases. And if the player is playing the note incorrectly and is a little flat, that is the frequency. The frequency decreases. So sound is often modeled by simple harmonic motion, because sound is just pressure waves, and pressure waves are modeled by this. Alright, example 3 we're going to save for the class so I can go over it together. But we're going to spend half the time writing functions and the other half trying to get functions from a graph. So here we have, we'll do this one and we'll do part B together in class. Write the equation of the function that represents simple harmonic motion. The first thing you need to decide is whether you're going to use a sine curve or a cosine curve. So if you look at this guy, he's starting in the middle. And whether he's increasing or decreasing, he's starting in the middle, which is a sine curve. So I know my function is going to look something like this. Okay? So once I know that, I need to find two things. I need to find the amplitude, and I've got to get the coefficient from the period length, and that's it. These really aren't that bad. If you look at your graph, looks like I have an amplitude of 4, so that's easy enough. But you can't see the scale on here. I need to fix that. The scale, every time it crosses, is a unit. So 1, 2, 3, 4, every time it crosses is another unit. So if I look at this, my period length is 2. Whatever my x value is, I have a period length of 2. So I'm going to put that in my formula. My coefficient is going to be 2 pi over 2, which is pi. So the final answer is 4 times the sine of pi t. There really isn't anything else to this. You choose which function you're going to use, you find the amplitude, and you figure out the coefficient from the period length. We'll do some more examples in class, and then tomorrow, or the next lesson, we're going to add a midline shift and a phase shift. And that's when it gets a little bit more complicated. But today, it really isn't that bad.